In this next part, we're going to focus on multiplying and dividing with scientific notation. Now, before we go into any example, the one thing I want to cover first is that in your final answer, you have to put it in the correct amount of decimal places according to the least amount from your given problem. So let me repeat. In your final answer, you want to have the least amount of decimal places according to what you were given in your problem. So for example, if you had one number with 5 decimal places and you had another number with 2 decimal places, you always want to go with the least. So if in another problem you had 4 decimal places and another number you had 1 decimal place, you always want to go with the least, 1 decimal place, in your final answer. So let me review. In your given problem, if one number has 5 decimal places, the other has 2, your final answer should go with the least, 2 decimal places. If in another problem you have 4 decimal places, and another number you have 1 decimal place, you always want to go with the least, so your final answer should have 1 decimal place for multiplying and dividing, and applies to adding and subtracting. So in our first example, we have 3.1 times 10 to the negative 4th power, 4.7 times 10 to the 8th power. Alright, from here, what we're going to do, when you have two scientific notation multiplied to each other, all I'm going to do is multiply 3.1 to 4.7. So it's going to be 3.1 times 4.7. And then my tens, so it's going to be 10 to the negative 4th power times 10 to the 8th power. Alright, now this one is based on the law of exponents with the same base, meaning 10, since they're multiplying, I'm going to add the exponent, so negative 4 plus 8. Alright, from there, I'm going to be working with 3.1 times 4.7. So 3.1 times 4.7. When I multiply, 7 times 1, 7. 7 times 3, 21. I'm going to skip or add a 0. 4 times 1, 4. 4 times 3, 12. Alright, so it's going to be 7 here, 5, 4, 1. And since I multiply, 1 decimal place, 2 decimal place. 1, 2. So it's going to be 14.57. So over here is going to be, emphasize my decimal point here. So 14.57. And then I'm going to simplify that. So it's going to be 14.57 times 10. Negative 4 plus 8 will be positive 4. And then since I simplify, I don't need the parentheses anymore. Now again, I mentioned before that our final answer has to have the same amount of decimal places as the least from the given problem, which is 1. Now before we do that, in the previous video I talked about where we need to have our number between 1 and 10. So in order to have it between 1 and 10, I will have to move my decimal to the left 1 time. Since basically I'm converting my standard to scientific, since I move 1 to the left, it's going to be 1.457 times 10 to the 1 power. And then I bring down times 10 to the 4th. Alright, so at the moment I have a number with 3 decimal places, but I want to round where I have 1 decimal place. So if I round, since it's 0.45, because of that 5 right there, and again, I wanted to have 1 decimal place instead of 3 decimal place, I want to round this 4, since it's 457, because of that 5 right here, I'm going to round up. So I'm going to be 1.5 times 10 to the 1 power times 10 to the 4th. Now, again, I round up because that 5 next to that 4. Here, since these two tens are multiplying, I'm going to add the exponent. So actually, my final answer will be 1.5 times 10 to the 5th power. This will be my final answer. So, to review, all I did was multiply 3.1 and 4.7, which became 14.57. I multiplied my tens together with the exponents, so the law of exponent was same base, add the exponents, which I got 10 to the 4th. Now, I had to convert 14.57 into a number that's between 1 and 10, which is 1.457, and I need to convert where it's 1 decimal place. So I'll round up to 1 decimal place because it is 5 right here. Since I moved my decimal to the left, that's where I get the 10 to the 1 power, 1 place. And I round up to 1.5. My final answer is 1.5 times 10 to the 5th power. In example 2, we have 2.5 times 10 to the 2nd power times 3.8 times 10 to the 5th power. So, I'm going to do 2.5 times 3.8 and then my 10 10 to the 2nd power times 10 to the 5th power. So this will be actually 10. Since they're same base multiplying, it's actually 2 plus 5 for the exponents. Alright, I'm going to do 2.5 times 3.8. You can skip forward if you know the process. I'm just going to write out the work. So 5 times 8, 40. Carry the 4. 16. So that's 20. Alright, 3 times 5. So carry the 1, 6, 7. 0, 5, 9. 2 decimal place. So 9.5. Alright, so I finished multiplying. 2.5 times 3.8 will be 9.50 or 9.5. Now the great thing about this is that it's actually between 1 and 10, and it's 1 decimal place. So we take a closer look. You see how in the original problem it has 1 decimal place, 1 decimal place. That's the least decimal place. So we don't have to do anything to the 9.5. We're pretty good. So what we're going to do now is I'm just going to bring down 9.5 down times 10 and add the exponent, which is 7. So I've basically multiplied together 9.5 again between 1 and 10, and it has 1 decimal place. So this is our final answer. In this next example, we actually have 15.39 times 10 to the 7th power divided by 2.7 times 10 to the 3rd power. So I'm going to combine my numbers together. So it's going to be 15.39 divided by 2.7 times, and then I'm going to combine my tens together. Now, law of exponent with division is going to be 10 top minus bottom, so 7 minus 3. That would be basically 10 to the 4th power. Alright, now I'm going to work my division. So 2.7 on the outside, dividing 15.39. Now since I want to work with whole number, not decimal, I'm going to move my decimal. Since this one has 2 decimal places, I'm going to move my other one also 2 decimal places. So when that happens, instead of 2.7, it's actually going to be 270. Instead of 15.39, it's going to be 1,539. Alright, so when we're dividing, I want to see how much 270 can go into 1,539. I'm not going to start with the 1, nor 15, nor 153 because it's less than 270. I have to go with 1,539. So basically I'm going to look at the 2 and the 15. 2 can go to 15 7 times. So let's try with 7. So 7 times 0, 0. And then you may skip 4. I'm just going to write out the work. 7 times 7, that's 49. Carry the 4. 2 times 7 is 14 plus the 4, that's 18. So that's going to be too high. So I'm not going to actually use 7. So let's try with 6. So 6 times 0, 6 times 7, 42, carry the 4. So 6 times 2 is 12, plus the 4, that's 16. That's still too high, because I want to go in a number that's below 15. So instead of 6, let's try 5. 5 times 0, and then 5 times 7, that's 35. Carry the 3. So 5 times 2 is 10, plus the 3, that's 13. That's less than 15, so we're good. Subtract. So 53 minus 35, 180. Alright. Next, I gotta keep going because I can't just stop there. So that means I'm going to add a decimal, meaning add a 0, bring it down. So it's now 1,890. So then I'm going to be looking at my 18. So 2 can go to 18 9 times. I could try 9, but if I do that, when I do 9 times 7, that's going to be 63. When I carry the 6, it's going to make the 18 higher. So it means it's going to be a number that's higher than 18. So I can't go with 9. I can go with 8, but if I do with 8, 8 times 7 is 56. When I carry the 5, so 8 times 6 plus the 5, that's 21. That's still too high. I could try the 7. When I do 7 times 7, that's 49. So I carry the 4. And then 2 times 7 is 14 plus the 4, that's 18. So let's try the 7. So 7 times 0, 0. 7 times 7 is 49. Carry the 4. 7 times 2 is 14 plus the 4, it's actually 18. So I can actually subtract and my remainder is 0. So 15.39 divided by 2.7 is actually 5.7. Now, looking at my decimal place, you see how on the original problem, top number is 2 decimal place and the denominator is 1 decimal place. You always want to go with the least amount, so 1 decimal place. Here, it's actually 1 decimal place already. I don't have to mess with the 5.7 because 5.7 is actually between 1 and 10. So we're good with that number. And then I don't have to do anything with the 10 to the 4th power. So my final answer is actually 5.7 times 10 to the 4th power. And that would be our final answer. We don't do anything about it. We're good. In this example, now we're actually going to be working with dividing in scientific notation. So, I'm going to work with the numbers together first, or write it together first. So it's 2, or should I say 22.1 over 3.4. And we're going to do the division work on the side. Next, I'm going to combine my tens together using the law of exponents, since its division is actually 10 top exponent minus bottom exponent. So 9 minus, don't forget, since I started with negative 2, I'm going to put parentheses on the negative 2. So if you are still unfamiliar with the law of exponents, I highly recommend that you go back and review with it. Now, let's talk about our division work. So it's 22.1 divided by 3.4. So I'm going to do 3.4 on the outside and then 22.1 on the inside. Now what I'm going to do, since I'm working with decimal, I'm actually going to move my decimal to convert it into whole numbers. So when I do that, I'm actually working with 34 dividing 221. So let's check. How many times does 34 go into 221? No, it won't go into 2. It won't go into 22, so we're going to make it as 221. So if I were to use 7, because it is 3, and 22, it would be 21, but I gotta be very careful because 7 times 4 is 28. If I carry the 2, it's going to be a number higher than 221. So let's try 6. So 6 times 4 is 24. 4 right here, carry the 2. 6 times 3 is 18 plus 2, which is 20. So it makes it 204. 221 minus 204, that would be 17. Now, I'm going to keep going. So that means I'm going to add a decimal here, add a 0, bring it down. Now it's 170. Now, 34 goes into 170. Now I got to think about the 3 and the 17. So maybe 5. Because 3 times 5 is 15, which is less than 17. So I'm going to put 5 up here. 5 times 4 is 20. Carry the 2. 5 times 3 is 15, plus 2 is 170. Subtract. My remainder is 0. So, 22.1 divided by 3.4 is actually 6.5 times 10. Simplify the exponent, so 9 minus negative 2 is actually 9 plus 2, which is 11. I don't have to mess with my 6.5 because it's a number between 1 and 10, and it's one decimal place. That's the least decimal place from the given problem. So my final answer will be 6.5 times 10 to the 11th power. So here's the work for division. When you're working with decimal, it's okay to convert into whole numbers. You just got to move the same amount of decimal places, the same amount of arrows. If you do that, you'll be fine. You're just may end up with a decimal answer, which is okay. And again, review with the law of exponents in order to work out for division, top minus bottom exponent.